Okay guys, let's take a look at today's lesson. We are going to begin our work on fundamental theorem of calculus. Okay. Now there are two parts to the fundamental theorem of calculus depending on which textbook you read. I love calculus textbooks. I know you probably can't imagine that. I have a lot of them. Some textbooks refer to this as part 1 and some refer to it as part 2. It just depends on the textbook. So I'm going to call this part 1. There are two parts and we're going to learn part 1 today. So part 1 has to do with definite integration, and we've been talking about definite integration. We've done it with geometric figures. Today we're going to learn how to do definite integration with the fundamental theorem of calculus. So let's go through the theorem and look at what it says. First of all, we need to be continuous on the interval. Okay? And so we have an integral set up. Notice that they're showing the derivative as the integrand, the first derivative as the integrand. We would find the antiderivative of it. We know how to do that. We've been working with that. And that would give us, in this instance, the position. Then what we do is we want to evaluate the position from A to B. A is my lower bound, and it's on the lower part of this bracket. And B is my upper bound, and it's on the upper part. And so basically, we just have to evaluate f of b minus f of a, and that is our definite integral. Yes? Yes. But it's a formula instead of doing it with area. Because unfortunately, you know, if the whole world were just made up of regular, like, rectangles and triangles and stuff, we really, I guess, wouldn't need calculus. But calculus allows us to calculate area under curves instead of just regular geometric shapes. So that's one of the cool things about calculus. All right, so here's the trick right here. We need to be sure to do f of b minus f of a. Earlier today, some of the students were getting it mixed up, and they were trying to put this one first. It matters. You have to do f of b minus f of a. You have to do it in that order or you're going to get the wrong answer. Okay? So let's practice that. Let's take a look at the first one. We have the integral from 1 to 2 of x squared plus 3. We do our antiderivative. So we get 1/3 x cubed plus 3x. We evaluate it from 1 to 2. You can do a bracket like I am. Some textbooks use just like a straight line. You can do a straight line. I mean, however you want to notate it. Now we substitute in. I'm going to put the 2, f of 2 in. So 1/3 times 2 cubed plus 3 times 2 minus. Here's where we also can make a lot of arithmetic mistakes. We are subtracting this whole f of a, not just the first term, but the whole thing. So I would recommend that you put a bracket there so that you don't lose track. So I'm subtracting, now I substitute a 1 in, and I get 1/3 plus 3. Now it just is some arithmetic. I don't mind if the arithmetic gets real intense for you to do the arithmetic on your calculator when you're doing your homework or daily work. I don't mind that. Certainly you're not going to have a calculator on a quiz or a test, so I'm not going to give you a real gigantic, intense arithmetic to do. But just so that you are aware, you can do that. Also, I encourage you to check your work on your calculator. It's fine. We learned yesterday how to input this in our calculator to see what the answer is, and that will help you in case you made an arithmetic error. It'll kind of show you, and plus I'll be walking around and working with you. Okay, good question. I had that question asked earlier. We do not have a plus c. I want you to think about what that would look like. If I had a plus c here and I had a plus c here, what would happen to them? They would cancel out, right? Because I would be adding whatever number it is, which we don't know, and I'd be subtracting the exact same number. So it's not necessary to put the plus c. It would just go away. Okay? On a definite integral. On an indefinite integral, we have to put the plus c because, you know, it's not going to go away. But on a definite integral, it would just net out to nothing. All right, so let's see. 2 cubed is 8, so I have 8/3 plus 6 minus 1/3 minus 3. And what, 8/3 minus 1/3 is 7/3. And 6 minus 3 is 3. So what is that? 5 and 1/3. Check my arithmetic. 16/3. Is that right? Okay. So that is our very first definite integral using fundamental theorem of calculus. We okay? Okay. The second one, we haven't learned algebraic substitution yet. And even if we had, it would be way easier to rewrite this rather than to try to do some fancy U sub on this one. So what I'm going to do is I'm going to think about it as two different fractions, and I'm going to rewrite it. So integral from 1 to 9, so x over x to the 1/2 resimplifies to x to the 1/2, and then 4x to the negative 1/2. That would make our life much easier and allow us to do just the plain reversal power rule if we just rewrote it. Alright, so let's do the reversal power rule. And we would add 1 to 1/2 and get 3/2. So 2/3 x to the 3/2 minus 4 times, let's see, add 1 to that, get 1/2, divide by 1/2, which is multiplying by 2. Okay, a value weighted from 1 to 9. Okay? We good? Alright, let's keep going. So I'm going to substitute the 9 in first. So 2/3, 9 to the 3/2 minus 8, 9 to the 1/2 minus. Now I'm going to sub a 1 in. We just really like ones. 2/3 minus 8. Now, some of you are probably familiar with evaluating fractional exponents, and some of you are probably not. So we need to discuss it. So this is a 9. I want to take the square root of 9 first and get 3. And then I cube 3 and get 27. I take 27 and divide it by 3 and I get 9. And I multiply 9 times 2 and I get 18. This mess is 18. Okay? I wouldn't. It's just more bigger numbers. I mean, you can, but I prefer to keep the numbers small, again, because I don't do arithmetic very well in my head. So I prefer to keep the numbers small. So here I have square root of 9, which is 3, and 3 times 8, 24, and then minus 2/3 plus 8. So what? That gives us a negative 6 plus 8 is a 2. 2 minus 2/3 is what? 1 1/3, which is 4/3. Okay? We okay? Alright. If we were to take the derivative of something and get secant squared, what would it have been? It would have been tangent. So we're going to evaluate tangent from 0 to pi over 4. So tangent of pi over 4 minus tangent of 0. So let's remind ourselves, pi over 4 is right here. It's where y and x are the same value. So tangent of pi over 4 is 1. Tangent of 0 right here. So that's sine over cosine. So sine would be 0, cosine would be 1. So it would be minus 0. And our answer is actually 1. Now we need to be real cautious. We need to be real cautious because if we assume that plugging in a 0 will be 0, 90% of the time we'll be okay, but about 10% of the time we're not going to be okay. Because what if we're plugging a 0 into e to the x? That's not going to be 0, right? It's going to be 1. Or what if we're plugging in 0 into cosine? That's not going to be 0, right? That's going to be 1. So please just be cautious when you're subbing in 0. Most of the time, yes, everything goes away, but not all of the time. All right, now on this number 4, I'm going to show you how to do it with an integral, but I would encourage you, if the absolute value is linear, only if it's linear, I would encourage you to do it the way that we did it yesterday. with just geometric formula. All right, so that's the way I'm going to do this, with a geometric formula. I'm going to write the integral for you and tell you how to do it with an integral, and we actually have one on the next slide where you can't do this way. But for this one, it just is quicker. It's quicker. If we're talking about timeliness, it would be quicker to do it with geometry, this particular one, if we can. So to do this with geometry, just to remember, we would find the vertex, and so the vertex is going to be at 1/2. And then it's going to be a V. We need to go from 0 to 3, so I sub a 0 in here, and I get a 1. So this will be at 1. We need to go to 3. I sub a 3 in here, and I get 5, so that would be at 5. I need that area and this area. So 1/2, my base of my first triangle is 1/2, my height is 1, plus my base of my second triangle is what, 2.5, so 5/2, and my height is 5. So I get 1/4 plus 25/4 gives me 26/4, or 13/2. Pretty straightforward, you know, pretty quick to do it that way. Now, just so that you know how to do it the other way, I'm going to show you how you would do it with an integral. Now, the issue with just integrating 2x, first of all, we can't integrate the absolute value of 2x minus 1. We know that by now, I hope. If we try to take the derivative of an absolute value, we get 2 derivatives. If we try to take, you know, a limit of absolute value, we get 2 limits, and if it's always 2. Right? So we try to integrate absolute value, we're going to get a minimum of 2 integrals to do. So, why? Let's see why. If I just integrate 2x minus 1, that's just a line, and it falls below the x-axis. What did we learn about the area below the x-axis versus the area above the x-axis? It's negative, so it's going to net out. It's not going to give us our proper value. It's going to net it out. All right, so what we have to do with an absolute value is we've got to do a sign chart. So we already know where it's 0, so we do a sign chart. On the left side, it would be negative, and on the right, it would be positive. And so when we're integrating, we would have to, on all the negative sections, we would have to force them to be positive by doing the opposite. So to set up this integral, I would need to do the integral from 0 to, look at my sign chart, I need to go to 1/2, 0 to 1/2, and that's a negative section, so I've got to do the opposite of it. 2x minus 1 dx plus the integral from 1/2 to 3 of just plain old 2x minus 1, because that's the positive part. And when I do those two integrals, which you can see is going to take a little bit of work, I would get 13/2. Now, on your calculator, you actually have an absolute value button on your calculator. So if you were going to be putting this integral into your calculator, if you have the absolute value button, which I'm pretty sure we all do, then you would just enter it like this in your calculator, and it would automatically do this for you. It's automatically going to do that for you. Okay? So just so that you know, that's how we would do it with an integral. We would do this little guy right here. Now, unfortunately, or fortunately, I guess how you look at it, if it's not linear, it's going to have curves, and we can't do a geometric formula for curves. We have to do it this way, which is the next one we're getting ready to do. Okay, so let's do the next one. Any questions so far? All right, let's go to the next one. All right, on this one, this is the absolute value of a parabola. Okay, and you wouldn't have to graph it. I mean, the graph isn't going to really help us, but I just wanted to demonstrate what that graph would look like. It would come like this, do that, and do that. Okay? So, we can't just do a geometric formula here. That's not going to be possible, because it's curved. All right, so we're going to have to do a sign chart. So x minus 2, x plus 2. We do a sign chart on it, and we get, yeah. So also, with the graph, I think we can probably tell which part was negative, right? Because we know what parabolas look like. This would be a parabola that would have been down 4, shifted down 4. You see the part that was underneath was reflected up. So we can tell by the graph that this part was the part that was negative. This would be between -2 and 2. But many times you're not going to have a graph. So there's my sign chart. So what I'm interested in is I'm interested in the area from -1, which would be like right here, all the way to 3, which would be like right out here. This is the area that I'm interested in. Okay, so let's write our integrals. The first integral is going to go from -1 to where? Where are we going to stop this integral? Okay, to 2. That's right, because -1 is inside here. We're going to go to 2. And this is where our y values for the normal function would be negative. So we're going to have to counter it. We're going to have to put a negative outside there. And then we would do x squared minus 4 dx plus, the next integral is going to go from 2 to 3. And that's where we're positive, so it would just be x squared minus 4 dx. Now would there be a situation where we would need 3 integrals instead of 2? Yes. What simple change could we have made on this problem to force us to do 3 integrals? Yeah, go from -3 or something, right? Then we'd have to do a positive one, then a negative one, then a positive one. All right, so just so that you know, it doesn't mean there's only 2. That just means there's a minimum of 2 if we have absolute value. So we work it through. We take the antiderivative, so that would be 3/1/3 x cubed minus 4x from -1 to 2, and then 1/3 x cubed minus 4x from 2 to 3. Now the negative being out here in front of here would really bother me with my calculations. I would go ahead and distribute this negative inside, just because that would really mess me up. I would forget which negatives were which. So let's go ahead and distribute it. This would be negative and this would be positive. Alright, so let's start. So we have a -1/3 times 2 cubed plus 4 times 2 minus, okay, that's my f of b, my f of a, -1/3 times -1 cubed plus 4 times -1, and that's my first piece, plus. So you can see why, if you can do it with the triangles, it'd probably be faster. Yeah, because this would be the same procedure that we would have done on the other page. I mean, just because it was a line wouldn't make it quicker. Alright, so now we do this next piece. So 1/3 3 cubed minus 4 times 3 minus 1/3, 1/3 2 cubed minus 4 times 2. And now it's arithmetic. And at this point, if you are just working on your daily work, I wouldn't mind if you put that in your calculator. But we're just going to keep going. So 2 cubed is -8/3 plus 8. Let's see, that would be, this turns into plus, so that's -1/3 plus 4 plus, so what, that'd be 27 divided by 3 is 9 minus 12 minus 8/3 and then plus 8. Okay, y'all checking my arithmetic? Hopefully. Oh, I have it written down. We'll look. So plus 8, yeah. Yep, it looks fine. So just, I'm not going to take you through all of that arithmetic. You will end up at 34/3 for your final answer after you combine all those together. Okay? So our last one is we want to find the area bound by the graph of this y equals 2x squared minus 3x plus 2 and the x-axis, and the vertical lines x equals 0 and x equals 2. So the parabola looks something like that. We want to go from 0 to 2, so we want to collect that area. So nothing unusual going on. In fact, you don't even really need to graph it, except it'll just help you understand what kind of answer you would get. So we're going to integrate from 0 to 2 of 2x squared minus 3x plus 2 dx. Okay, we would do our reversal power rule. So that would be what? 2/3 x cubed minus 3/2 x squared plus 2x from 0 to 2. Oh, we love 0 most of the time. We sub a 2 in, so we get 2/3 2 cubed minus 3/2 2 squared plus 2 times 2 minus 0, because 0 is nice to us here. Alright, so what is that? 8, so it's 16 cubes over 3. What is that? 4, 5, so it's 6 plus 4. So what? Negative 2 plus 16/3. And that ends up being 3 1/3 or 10/3. Okay. How are we with our first look at definite integration with fundamental theorem of calculus? We okay? All right, let's practice.